All right, so hope everybody had a good 3-day weekend. Did not see you on Friday. We just took care of the homework. If you have any questions, please let me know. You got a quiz on that Thursday. It shouldn't be too bad because, again, it's all on the calculator. That is one of the few items I am not showing you how to do by hand. I'm just not going to worry about it because it would take up more time, and it's just not going to be beneficial to you, I don't think. Not that particular item. I'll give you your next homework assignment tomorrow over this current lesson. We'll go ahead and make it due on Friday, give you a couple of days to go ahead and get that taken care of. But big picture, what's happening Monday? Monday is your second exam. Okay, now we really want to be thinking ahead to this because not this Friday, next Friday is already what? The end of the first 6 weeks. Okay, it's going fast. So we're going to have, several grades left. We have the homework assignment I just mentioned, the one we just turned in. We'll have another quiz grade. We have the exam, which is the biggest. We'll have the focus activities we're going to turn in, the second set. So that should be another guaranteed grade. And at the very minimum, that's 5. Maybe we'll go ahead and get another exit ticket or in-class assignment. But the big one we want to be taking a look at is the test for Monday. So I did put one review problem on there over cumulative frequency. Okay, so you want to revisit that. What's IQR again? Interquartile range. Now, is that the difference between the max and the min, or Q1 and Q3? Q1 and Q3. Okay, so you want to revisit that. That's problem number 1. But then right after that, I put standard deviation. There's going to be some normal distribution problems on there. And then to finish it up, I went ahead and put some correlation where you're going to find that value of R. Okay, so all that's coming up on Monday. Any questions? All right, well, let's see what we got here. When we're talking about correlation, I'm hoping this is what comes to mind. Does anybody remember what we call these graphs? What kind of plots? Scatter plots. Okay, this is a quick visual comparison of 2 quantities that we may be comparing. And when we're talking about correlation, it's a numerical value that basically describes the strength, okay, of the relationship that they may have, or maybe that there's no relationship at all. Okay, you see what we have here? We can have a strong positive, we can have a moderate positive, a weak positive, and we're going to get into this in a little more detail in just a little bit. But I really want you to think that any graph you have ever come across in your life, it has been a scatter plot. It just has to do with the association. Like, for example, if you have a linear function, all those xy points, they form a specific relationship. They're all collinear. That's what we call a perfect association. The same thing for a parabola. Okay, the x and the y's relationship, okay, is to create that U-shaped graph that we're familiar with. So when people tend to think of scatter plots, they don't lump in the graphs that you've seen. They just kind of think about these right here. Okay. Now you'll notice, what are we seeing with the placement of the dots when it's strong and when it's weak? Yeah, they're closer together. The closer, the more tightly packed those points are, the stronger the association is. Okay, so on the other side of that, the further apart they are, the weaker the association is going to be. We say that's a very weak relationship. Is it, in fact, possible to have no correlation at all? Yeah, it's very possible that one quantity has in no way any effect on another. And this is, what we're trying to figure out today. So if it rises to the right, we can say it's positive. If it falls to the right, we can say it's negative. So this is just a little bit more information for you here. It's one of the sheets that I went ahead and provided for you today. So let's go ahead and get right to an example. Oop. And it looks like I totally forgot to go ahead and erase this from last time. So if you'll just give me 1 second. Pay no attention to the man behind the curtain. That's a Wizard of Oz reference in case you weren't knowing. All right, let's go ahead and run with an example. Just a simple example. I want to go ahead and give you the formulas. I like to do this kind of like with standard deviation, where I gave you just a real simple example to kind of introduce you to it, and then we got right into the notes. Well, there's 3 formulas that you're going to be using here. We call them S sub xy, S sub x, and S sub y. Now, S sub xy, you're going to come to know this formula as the covariance. Okay, so this is if I'm going to go ahead and take the sum, if I could write a summation symbol here, the sum of x minus its mean times y minus its mean divided by n. Okay. Let me make sure I'm remembering this correctly off the top of my head because I don't want to make a mistake. Okay. Of course it's perfect. Very quiet when I said that. Okay. Now for S sub x, this is where everything's going to be below a radical. You're still going to have a quotient. You're going to take the summation of x minus its mean squared divided by the number of terms that you have. And the same thing is going to be for the S sub y, just y in place of x. Okay, so we have a summation here, and that's going to be y minus its mean squared. And that is a horrible summation. Let me see if I can do that better. This is that capital sigma. Another math teacher is probably going to watch this video and have a heart attack with how I'm drawing those symbols, but there you go. Okay, so S sub xy, this is what we call the covariance. Okay, now S sub x and S sub y, do those actually look familiar at all? It's something we've been talking about very recently. That's right, Arias says standard deviation. S sub x is the standard deviation specifically for the x's. S sub y is the standard deviation specifically for those y values. Now, all three of these are going to work together to help you figure out what your correlation coefficient is. You might remember back in Algebra 2, we went ahead and used R as the variable for that. Okay, did you guys ever do that in Algebra 2? Look at scatter plots and find a prediction equation, things like that? No, really? Okay, but that's all right. R is the variable we use to go ahead and represent what the correlation is. Now remember, it could be very strong, it could be weak, positive, negative. But here's what you do in order to find R. You take S sub xy, the value from the formula, and you divide it by the product of the standard deviation for the two quantities you have. Okay. Now it looks way worse than it really is because those are some pretty large formulas, but I got a simple table here. Let's just go ahead and run through, show you how easy it is. Okay. We won't actually be even using the formulas themselves to begin with. I just kind of wanted to throw these out there so you knew what was coming. All right. So here's my problem. It says Sue investigates how the volume of water in a pot affects the time it takes to boil on the stove. The results are given in the table. All right, find and interpret Pearson's correlation coefficient. Okay, that's the R that I was talking about between the two variables. All right, so I'm going to go ahead and create a table because, you know, tables really do a lot of work, a lot to help us organize all of our data, right? So I'm going to take my X's and my Y's. I'm going to start by listing them. So we have 1, 2, 4, and 5 liters. And then for the Y's, we have 3, 5, 7, and 9 minutes. 3, 5, 7, and 9 minutes. Okay. Now, think about those formulas. We need certain things. I need X minus its mean. I need Y minus its mean. I need a product of the two. Okay, hopefully I left myself enough room here. And what are some other columns I need? Think about those formulas. There's something else I need to do with those differences.
Square root of.
Now, square root.
Divided by the total.
Square them. There we go. So X minus its mean squared and Y minus its mean squared. All right, so just enough room on my screen. All right. So first off, in order to do any of these other columns, I need to know the mean, the average, for my two quantities, the volume in liters and the time in minutes. So let's see here. How many liters are we looking at? 1 plus 2 plus 4 plus 5. 12. Okay, so the mean for the x's would be 12 divided by, we have 4 elements, right? So I'd say that my mean is 3. Okay. Let's do the same thing for the y's. All right, so let's see here. 3 plus 5 plus 7 plus 9. 24. So 24 minutes total, divided by, again, the 4 elements. That would give me 6. Okay. Is everybody okay with what I've done so far? Okay. Well, now we can go ahead, because we know the means, we just start to fill in our columns here. Now, when it says x minus the mean, that means I want to take each element individually and go ahead and subtract what we just found. So the first x is 1, so what's 1 minus 3? Negative 2. 2 minus 3. Negative 1. 4 minus 3. And 5 minus 3. 2. And while we're at it, since we're looking at these values, why don't we go ahead and take care of the squared column. So what happens when I square a negative 2? 4. Okay, so that would be a 4. And then 1 squared, whether positive or negative, would be 1. And then 2 squared is another 4. Okay. Well, now let's take care of the y minus its average. So this time it's 6, so 1 minus 6. What? Oh, yes. I was just saying if you're paying attention. Always got to keep you guys on your toes. So 3 minus 6 is negative 3. 5 minus 6? Negative 1. 7 minus 6. And 9 minus 6. There we go. And now let's go ahead and square this column for the last one. So that's going to give me 9, 1, 1, 9. Okay. So the only thing I have left is to go ahead and multiply the 2 columns of the differences. And this table is almost done. So let's see here. Negative 2 and negative 3, 6, 1, 1, 6. Okay. So any questions on how I'm setting this up? Basically, I've almost kind of unpacked or just dissected those formulas, okay, instead of plugging into them directly. Okay. Now, remember S of xy, and I actually have these down here. Just really need to remember to erase those before I start the next class. Okay. So S of xy, what I need to do here is take what total? Remember, look at the formulas that I just gave you. Okay, for S sub xy, remember that was the summation of x minus its mean times y minus its mean divided by the number of terms that we have. Okay, well, let's take the sum of this column. 6 plus 1 plus 1 plus 6. 14 divided by, how many terms do we have? 4. Now, you're looking at them in each set. We're not looking at the total number of terms, both x and y, just the number that each set has. So each set has 4. So that would be 7 halves. So it would be, let's just make it a decimal. 3.5. So that's my covariance. Okay. That's my covariance. This total right here would be 14. Let's go ahead and take a look at my standard deviation. All right, so the standard deviation for x, this was below a big radical. So this was the sum of what?
X minus mean of x squared.
Okay, so x minus its mean squared, again divided by the number of terms that we have, right? So this is a square root. So we need the sum of this second to last column right here. So 4 plus 1 plus 1 plus 4. 10. So that would be 10 divided by 4. So right now, I'm just going to go ahead and leave it as the square root of, let's say, 5 halves. Or if you want to go ahead and say 2.5, that's fine. Okay. And now we got one more to do. This is the standard deviation for the y. So I need the summation of the difference between y and its mean squared divided by the total number. All right, so what's this last total we're looking for? 20. So 20, once again, divided by the 4 terms. So this is the square root of 5. Now remember, how did I say these 3 work together to give me the correlation?
Correlation variable. Adding up that.
That's true. Okay. So R is my correlation variable. What went on top? S sub xy, the covariance. So S sub xy. And then what did I do down below? There you go. I took a product of those standard deviations. So S sub x times S sub y. So in order to find R, based on what I've got here, I'm going to take 3.5, and I'm going to go ahead and divide it by the square root of 5 halves, which I'll probably just go ahead and say 2.5, times the square root of 5. And then we can go ahead and plug this in the calculator. Now, we can probably go ahead and just simplify things instead of my putting two radicals. What's the square root of 5 halves times the square root of 5? 10? It'd be the square root of what?
5 over root 2.
Well, we're not going to rationalize it. It would be just 25 halves, right? Or 12.5? Because I'm just multiplying the radicands? Everybody's okay? So I'm just going to go ahead and plug that in. 3.5. So control divide, and it's still doing green. So let me come on over here to my trusty keyboard. All right, so control divide. So we have 3.5 divided by, so instead of putting two different radicals, I'm just going to go ahead and say 5 halves times 5 is 25 halves, or 12.5, right? Okay, would you agree? Okay. Well, they're both radicals, so I'm taking a product of that. So the square root is going to be the standard deviation. Remember, we just haven't calculated that yet. If I were to square it, 12.5 would simply be the product of their standard deviations. Okay. So I go ahead and push enter, and I'm getting 0.9899. And how close is that to 1? Ridiculously close. That's very nearly a perfect association. So would you say there's a relationship between the amount of water needing to boil and the time given to do so? I would definitely say there's some kind of connection there. Okay, now that's the whole process. That's how you would do it by hand. Now again, this is something I think is going to make you appreciate the calculator a little more, but if in your IA, your internal assessments, you want to go ahead and compare a couple of sets of data, if you want to go ahead and do so visually with a scatter plot, or even better, use Pearson's correlation coefficient, this is what you're going to have to do. You know, you can't just say, okay, I typed it in the calculator, this is R. They're going to want you to walk the reader through this. So if you're going to decide to use this strategy in your data, you'll probably want to have yourself maybe a little snippet of an Excel spreadsheet, or maybe just some kind of table where you can walk through. Now, you can show the values. You don't have to do everything, but at least make the reader aware of how we got to that value. Does that make sense? Okay. All right. So let me go ahead and show you this, because now you've all been waiting for it. That's by hand. How would we do this on the calculator? Well, I'm glad you asked. Okay. Let's do this. Let me go ahead and now remember this right here. This is what we got for R. This is my correlation coefficient, right? Okay, so I'm going to go back here. Now I need to put the data into the spreadsheet. So how do I get there? Okay, so I can either go down here to this icon, or I can choose number 1, whichever you want to do. Okay, list the spreadsheet. So I'm going to go ahead and type in, and you can type in liters and time. Again, I just usually go ahead and put X and Y, whatever you like. What about this row here? I keep forgetting. Leave it alone. Don't put anything in that row. Okay. Now, I don't remember, what were the values? What were the liters? 1 what? 1, 2, 4, 5. Okay. And then the time, how many minutes did we have? 5, 7, 3, 5, 7, 9. Okay, so let me come back up here. 3, 5, 7, 9. There we go. Okay, so just like before. Okay, so you already know. Menu. Statistics. We're back to stat calculations. Yes, because we're comparing two different sets of data, this is when we're going to choose two variable statistics. If we're dealing with a frequency table, remember that's just one variable. So I'm going to go ahead and click enter. And now we want to go ahead and delete this. Okay. For the X and the Y list, we're going to go ahead and make sure that we're using those headings that we put in so it knows what data specifically to use. So tab right here, Y. Now here, there's no frequency list, so I'm just going to go ahead and get rid of that. Everything else is okay. We don't have to worry about category list, include categories, but all my information will show up in what column? D. So as soon as I push enter, here we go. Now think back to everything we found on the problem. What did we find for the mean of the X's? We found 3. What did we find for the mean of the Y's? 6. Now let's do a quick comparison. For the standard deviation of X, we got the square root of 5/2, right? Standard deviation of Y, we got the square root of 5. Well, let's do this very quickly. Let me come on over here at home. Calculate. So the square root of 2.5, so 1.58. And let's go ahead and type in the square root of 5, about 2.24. Okay. Now, if I come on over here to my table or my information, current document, here we go. There's the standard deviation for the X's, the 1.58 that we just found. What do we get for the standard deviation on the Y's? 2.24. Okay, so all the information is coming out correct. In fact, what do we get for R, the correlation coefficient? We got like 0.9899, right? Well, if I continue to scroll down, there's R. Okay. There's everything we need. Emily, you doing okay today? Huh. Oh, okay. Sorry about that. Okay. All right. And then it goes on to even give you the information for a box and whisker plot. Minimum, maximum, median of all that stuff for both the X's and the Y's. It does separate it because you're not going to have a box and whisker plot for both. There you go. So you have a lot of information here. It's very, very similar to your frequency tables. It's just this time you're choosing 2 variable statistics instead of just the 1. Okay. How's everybody doing? Great. Yes, ma'am. I mean, you won't be borrowing these, but I can let you borrow the older versions if that'll work. Oh, yeah. Yeah, they're still TI Inspires. I don't believe they're CXs, but they'll still work. Okay. All right. Anything else? Okay, so I'll tell you what. It is only 2:01. But we not only got through one by hand today, we got through one on the calculator. We'll go ahead and pick up with this tomorrow on the notes. We'll continue correlation. I'll give you your assignment tomorrow, and then we'll move on. Remember, what's happening Monday? Test. Will this be on the test? Yes. Okay, so again, what's really going to play into your favor, you want to know the keystrokes, standard deviation, normal distribution, correlation, and remember I did throw a review problem on there. What was it? Cumulative frequency. Okay, so one other thing I want to go ahead and mention, starting on Thursday, and every Thursday, now I don't know if it's going to be just this semester or if it's going to be the entire school year, but on Thursdays, we're going to have a student candidate from Texas Tech University, someone who is going into the profession of education, is going to be coming in here with us, and from time to time, she might even be teaching you, she'll be grading, she'll basically be shown everything there is about being a teacher. Oh, what's that? The wonders of education. I can say one thing truthfully about this job. It's never boring. It's never boring. Years ago, I had a young man just stand up in the middle of the class and drop his shorts.
Really?
Why? He felt like doing it. So there you go.
Dude, that's awesome.
In today's climate, I would say no. Oh, okay. Yeah, there you go. Yeah. But just to let you know, and I'll be introducing you to her on Thursday, and we'll just see. All right. Thank you very much, guys. Appreciate it.